Hello everyone, welcome to another episode of PLC programming. And today's quick topic is PTO interface. We are going to discuss what is PTO interface, what are the minimum requirements, and what are the parameters that we configure. So PTO stands for pulse train output, and the minimum requirements to use pulse train output to control a servo. We must have a PLC which is supporting high speed outputs. Its hardware configuration, the controller must have the high speed outputs in its hardware, and then we must have the servo drive which can accept high speed inputs, or also called as pulse train input. These are the minimum requirements to have a system where we can use PTO interface. And this is the typical wiring diagram for the PTO. If you see, we are sending pulse and direction from controller to servo, and then enable means power on, power enable, and ready to switch on. So what is the procedure? First we are getting ready to switch on signal from servo says that okay, now the power can be enabled, and then from PLC we enable the power by sending a digital output, and then based on the commanded position and velocity and direction we are sending pulses and direction signal. This pulse signal generally it is 24 volt, and direction signal is also 24 volt. And the frequency for the pulse signal is, it depends on the hardware. Some vendors support 100 kilohertz, and some vendors also support 200 kilohertz as pulse frequency. The more is the frequency, the better will be the resolution, or in simple words, better will be the accuracy. And then we can also use PTO in a configuration where one servo can be following the other servo. So in this way, controller is providing these signals to one servo, and then we are using simulated output from that servo drive to the follower servo drive. And we also have the possibility to set certain gear ratio, that we can change the relation between the main servo and the follower servo. We can make it in that way that if the first servo or the master servo is moving two rotations, then the follower servo can move only one rotation or rotate only one rotation. That is also possible. And on the parameter side, we need to decide how many pulses we need for one motor revolution or one servo revolution. That is, from that calculation we are finding the denominator and nominator. So numerator and denominator we are using, and we are configuring inside the servo drive. So based on that, servo drive is accepting and analyzing, and then doing the internal computing for the pulses which it is receiving from the PLC. Okay guys, this is all on the pulse train output. It's a very quick episode, and maybe we will make one more quick episode where we will decide how we can finalize, or how we can decide, we can design that how many pulses we need for particular accuracy, or what will be the accuracy based on our configuration, that we can do with a real example. And this is all for this video. Thank you very much.